Welcome to the Blue Collar Tutor Test Preparation Series for the New York City Fire Department S-12 Certificate of Fitness for Citywide Supervision of Sprinkler Systems. This series will provide you with a convenient review of the material for the written exam. This preparation course includes information taken from the 2008 New York City Fire Code, Chapter 9, Fire Department Rules, Chapter 9, and the National Fire Protection Agency, Standard 25, 2002 edition, for inspection, testing, and maintenance of water-based fire protection systems. It is critical that you understand this material to help increase your chances of passing this exam. A transcript of this material is provided for free by the New York City Fire Department. See the link in the description below to upload the transcript and additional reference guides that you'll need to familiarize yourself with for the exam. Instructions on the application process to register for the exam are also provided via the link below. Once you've familiarized yourself with all of the material in this course, continue on to the practice test sections at the end of the series. There you will find over 200 questions to test your knowledge of the material. The S-12 Certificate of Fitness is required in New York City for individuals who inspect, test, and maintain citywide sprinkler systems. This certification is typically held by building engineers, maintenance personnel, and fire safety directors. Holders are responsible for ensuring the proper functioning of sprinkler systems in New York City buildings. The certificate signifies that an individual possesses the knowledge and competency to meet the fire department's requirements for sprinkler system supervision. To obtain and keep the S-12 certificate, an applicant must 1. Be at least 18 years of age. 2. Have a reasonable understanding of the English language. 3. Apply by submitting a completed application form, providing 2 forms of identification, including a photo ID. At least one identification must be government-issued photo identification, such as a state-issued driver's license, a non-driver's license, or a passport, and pay the application fee. 4. Pass a written, multiple-choice exam on sprinkler system components, maintenance, and relevant fire safety regulations administered by the New York City Fire Department. 5. The certificate must be renewed every 3 years. The fire department will send a renewal notice 90 days prior to expiration. 6. Certificate holders are responsible for being familiar with the latest fire code and related study materials. Exam information. The S-12 test will consist of 75 multiple-choice questions. The test is time-limited to approximately 135 minutes. A passing score of at least 70% is required in order to secure a certificate of fitness. All questions have 4 answer options. Only one answer is correct for each question. If you do not answer a question, or if you mark more than one answer to a single question, your answer to that question will be scored as incorrect. Read each question carefully before marking your answer. There is no penalty for guessing. The temperature ratings, classifications, and color coding chart, along with the inspection, testing, and maintenance of sprinkler systems activities and records, Chapter 13 of the FDNY transcript, will be provided to you when you take the exam. Make sure to print out a physical copy of this chapter to use while taking the practice exams. Familiarizing yourself with this chapter will ensure that you complete the test within the allotted time. Before you take the test, check for the latest revised material at the New York City Fire Department via the link in the comment section below. Hopefully this orientation answered some of the questions that you may have had. Post any follow-up questions in the comment section below. Subscribe to stay current on updates to existing exams and to be notified of new test preparation content. If you find this video helpful, please consider leaving a like. Chapter 1. Introduction. A sprinkler system is a fire extinguishing system, other than a water mist system, that utilizes water as the extinguishing agent. Whether a building shall be provided with sprinkler protection or not is generally set forth in the New York City Building Code. The Fire Code, however, does contain several sprinkler requirements, such as for the high-piled combustible storage and for buildings constructed on streets of substandard width. Inspection, testing, servicing, and other maintenance of sprinkler systems must be personally supervised, Fire Code 901.6.3, and be performed in accordance with National Fire Protection Association Pamphlet No. 25, 2002 edition. All multiple dwellings, factories, office buildings, warehouses, stores and offices, theaters and music halls, and all hospitals and asylums, and all public schools and other public buildings, churches and other places where large numbers of persons are congregated for purposes of worship, instruction, or amusement, and all piers, bulkheads, wharves, pier sheds, bulkhead sheds, or other waterfront structures, shall provide such fire hose, fire extinguishers, buckets, axes, fire hooks, fire doors, and other means of preventing and extinguishing fires as the Commissioner may direct. Required fire protection systems shall be extended or altered as necessary to maintain and continued protection whenever the building or structure is altered. Fire Code 901.4.1. Systems not complying with this section shall be considered to be impaired. It shall be unlawful to install or maintain any fire protection system or device that has the physical appearance of fire protection equipment but that does not perform a fire protection function where it may be confused with actual fire protection equipment. Fire Code 901.4.4. An example would be a closed-circuit television camera modeled to look similar to a sprinkler head. Sprinkler and/or standpipe system maintenance and inspections. Fire Code 903.5. 1. Automatic and non-automatic sprinkler systems shall be inspected, tested, and maintained as required by the National Fire Protection Association 25, 2002 edition, by a competent person holding a certificate of fitness employed by the owner to see that all parts of the system are in good working order and that the fire department connection or connections, if any, are ready for immediate use by the fire department. A detailed record shall be kept of each inspection for examination by any representative of the fire department. 2. A supply of at least 6 extra sprinkler heads shall be kept available on the premises to replace promptly any fused or damaged sprinklers. Any head which has opened or has been damaged shall be replaced immediately with a sprinkler head of similar characteristics such as operating temperature, orifice size, deflector orientation, and thermal sensitivity. 3. At least once in 5 years, the fire department connection or connections for a sprinkler system shall be subjected to a hydrostatic pressure test to demonstrate its suitability for fire department use. The test shall be arranged to be conducted by a master fire suppression piping contractor in the presence of a fire department representative. The contractor shall be hired by the owner or the owner's representative. 4. There shall be 1 or more employees with a certificate of fitness to inspect the sprinkler system following the standard of the National Fire Protection Association 25 of 2002. Chapter 2. Responsibility of the building owner. It shall be the owner's responsibility to maintain the sprinkler system and to determine the individual qualifications and competencies of the individual, his certificate of fitness holder, to perform certain functions related to inspection, testing, and maintenance. Fire Code 901.6.2. Records. Records of all system inspections, tests, servicing, and other maintenance required by this code, the rules or the reference standards shall be maintained on the premises for a minimum of 3 years and made available for inspection by any department representative. Fire Code 901.7.1. Impairment Coordinator. The building owner shall assign an impairment coordinator to comply with the requirements of this section. In the absence of a specific designee, the owner shall be considered the impairment coordinator. The building owner or their agent shall assign an impairment coordinator to maintain records of all system inspections, tests, servicing, and other items of maintenance shall be kept on site for a period of 3 years and made available for inspection by any member of the FDNY. In absence of a specific designee, the building owner shall be considered the impairment coordinator. Chapter 3. Out-of-service systems. Planned removal from service. When the system or a portion of the sprinkler system is placed out of service for a scheduled inspection, testing, regular maintenance, minor repairs, or for construction affecting not more than 1 floor, the certificate of fitness holder and the impairment coordinator shall be made aware of and authorize the placing of the system out of service. Unplanned out-of-service condition. A serious defect in the sprinkler system including, but not limited to, an empty tank, a break or major leak in the system's water piping, inoperative or shut water supply valves, defective fire department connections, construction-related shutdowns affecting more than 1 floor, or complete or partial shutdowns of the sprinkler system other than a shutdown for a planned removal from service. Fire department notifications for out-of-service conditions. A. For a planned removal from service, no notification to the fire department is required, provided the system will be returned to service within an 8-hour period, and when all other fire protection systems in the building, standpipes and alarm systems, are fully operational. B. For an unplanned removal from service as described above, the certificate of fitness holder, impairment coordinator, and/or other person responsible for inspecting, maintaining, or supervising the operation of a fire protection system shall immediately report such condition to the owner of the building and to the Fire Department Borough Communications Office. Fire Code 901.7.5. C. The initial fire department notification shall include the following. 1. A brief description and extent of the out-of-service condition. 2. The area of the building affected. 3. The type of occupancy. 4. The estimated time the system will be out of service. 5. The name and phone number of the person making the notification. D. When the certificate of fitness holder observes a minor defect or other condition not presenting a serious safety hazard, he or she shall report the defect or condition to the owner, and if the defect or condition is not corrected within 30 days, it shall be deemed to be an impairment and reported in writing to the fire department. Fire Code 901.7.5. Identifying out-of-service systems using disks/tags. Systems that are out of service, both planned and unplanned, shall be immediately identified by placing a tag at each of the following locations: fire department connections, system control valves, fire command center, or other clearly visible location in the lobby of the building indicating which system or part thereof is out of service. Impairment coordinators/building owners shall ensure the placement of these tags by a master fire suppression piping contractor or a master licensed plumber as restricted. In addition, for an unplanned out-of-service condition, a disc, white or blue, shall be placed at all affected fire department connections to inform responding fire department units of the out-of-service condition. The impairment coordinator/building owner shall ensure placement of these discs by master fire suppression piping contractor, a master licensed plumber, as restricted, or fire department units. When the condition has been corrected, the discs shall be removed immediately. Tag requirement. A tag shall be used to indicate that a system or portion is out of service. Fire Code 901.7.2. A master fire suppression piping contractor Class A or B, or a master plumber, as restricted, shall be required to post tags at the main control valve and at any closed sectional valve serving areas affected. The tag shall indicate the area affected, a brief description of the condition, the occupancy classification, C of F number, and the estimated time until the system becomes operational. Drain test results shall be posted on the tag indicating both the static and flow pressures before and after the system was placed in an out-of-service condition. If no impairment is found in the entire system, green tags will be placed on the main control valve. Systems partially or fully out of service. Fire suppression piping systems equipped with fire department connections shall follow the following procedures for identifying systems out of service. Systems fully out of service. The impairment coordinator/building owner shall ensure that the local administrative fire company, a master fire suppression contractor, Class A or B, or a master licensed plumber, as restricted, has placed one white disc 8 to 9 inches in diameter on all affected fire department connections. A red tag shall be placed at the main control valve indicating the sprinkler company name, date of removal from service, and anticipated return to service date. Systems partially out of service. The impairment coordinator/building owner shall ensure that the local administrative fire company, a fire suppression piping contractor, fire department units, or a master fire suppression contractor Class A or B has placed one blue disc 8 to 9 inches in diameter on all affected fire department connections. A red tag shall be placed at the main control valve and any closed sectional valve indicating the company name, date of removal from service, and the anticipated return to service date. The certificate of fitness holder and the impairment coordinator shall be made aware of and authorize the placement of systems out of service that are planned to be shut down. The impairment coordinator, prior to taking a system out of service, shall determine the duration the system is to be out of service, inspect the areas of the building affected and assess the increased risk, notify the insurance carrier, the central station operator, if so equipped, the occupants of the affected area, and place out-of-service tags and discs at the appropriate locations. Fire Code 901.7.4. Impaired equipment. underground service mains, water storage tanks, fire department connections, control valves, fire and/or booster pumps that are out of service and are considered vital to part of the system that are required to be tagged following procedures outlined in Chapter 14 of the National Fire Protection Association, number 25, 2002 edition. Tags placed at control valves shall indicate the level of impairment or defect as follows. System fully out of service, red tag, white disc. System partially out of service, red tag, blue disc. System appears free of defects or deficiencies, green tag, no disc. Only the New York Fire Department, the owner, a master fire suppression piping contractor, or master licensed plumber, as restricted, may place a tag on a system. For systems that are fully or partially out of service that are not equipped with fire department connections, the appropriate tags shall be placed at the main control valve. The fire department is to be notified immediately. In a building required by the New York City Fire Code to have a fire safety director with an F58 or F25 certification, or an engineer with Q01 and Q99, certifications with the S-12 certificate of fitness, both are authorized to take the system out of service for less than 8 hours and place an appropriate colored tag on that system. The fire safety director and the engineer must be on the premises at all times. Prior to returning a system to service, the impairment coordinator shall ensure that the necessary tests and inspections are conducted to verify that the system is operating normally, notify the fire department borough dispatcher, the building owner's tenants in the affected area, the insurance carrier, central station operator if so equipped, and remove out-of-service tags and discs. Fire Code 901.7.6. Protection of sprinkler systems. All parts of an automatic system exposed to freezing temperatures shall be protected from freezing, or in lieu thereof, an automatic dry pipe system or a system filled with a non-freezing, non-combustible solution shall be used. When a system filled with a non-freezing solution is used, and the system is connected to a potable, drinking water supply, it shall be subject to the requirements of the Health Department and the Bureau of Water Supply of the Department of Environmental Protection, and may require that a backflow preventer be installed. Approved non-freezing solutions, including glycerin, not greater than 50%, and propylene glycol, not greater than 40% non-freezing solution. Sprinkler heads subject to damage shall be protected. Chapter 4. General Procedure for Record Keeping, Impairments, and Safety. It shall be the responsibility of the certificate of fitness holder to perform the following. Record keeping. The certificate of fitness holder shall maintain a detailed record of all inspections. A record with the date of each inspection, the certificate of fitness number, and the signature of the certificate of fitness holder shall be posted near the main control valve. A detailed inspection report shall include information relative to conditions of water supply, gravity and pressure tanks and levels therein, valves, risers, piping, sprinkler heads, and fire department connections, alarms, fire, booster, and special service pumps, obstructions and conditions of all other system equipment and appurtenances. All defects and/or impairments shall be noted on the report. Records shall be readily available to any representative of the fire department. These records are to be maintained on site by the building owner for 3 years. Notification of all defects shall be reported to the owner or their representative by the certificate of fitness holder. After 30 days, any of the defects that have not been corrected shall be immediately reported to the Fire Department Borough Communication Office. Failure to make inspections, maintain records, and report defects or violations may be cause for revocation of the certificate of fitness and court enforcement proceedings. Chapter 5. Individuals authorized to perform tasks as specified in the New York City Fire Code. 1. An S-12 certificate of fitness holder can conduct visual inspections only, provide proper notification and record inspection results for examination by the fire department. 2. An S-12 certificate of fitness holder of a single or multiple properties under common ownership employed by a site-specific building owner with the following certifications. Refrigeration operating engineer with the refrigeration Q99 and Q01 licenses, a high-pressure operating engineer, and a New York State high-pressure operating engineer are permitted to perform visual inspections, test notification appliances, perform daily and weekly routine maintenance, and record all inspection, testing, and maintenance results for examination by the fire department. 3. A master fire suppression piping contractor, A or B, with an S-12 certificate of fitness, can inspect, test, maintain, and repair/replace all fire standpipe and sprinkler systems components, record maintenance, inspection, and test results for examination and evaluation by the fire department. 4. A master plumber with an S-12 certificate of fitness is limited to residential occupancies with 30 sprinkler heads or less, without a booster pump. Chapter 6. Definitions. Antifreeze sprinkler system. A wet pipe sprinkler system employing automatic sprinklers that are attached to a piping system that contains an antifreeze solution and is connected to a water supply. The antifreeze solution is discharged, followed by water, immediately upon operation of sprinklers opened by heat from a fire. Combination standpipe and sprinkler system. A system where the water piping services both 2.5-inch or 65mm outlets for fire department use and outlets for automatic sprinklers. Concealed sprinkler. A recessed sprinkler with a cover plate. Control valve. A valve controlling flow to water-based fire protection systems. Control valves do not include hose valves, inspector's test valves, drain valves, trim valves for dry pipe, pre-action and deluge valves, check valves or relief valves, S-Y valve, outside stem and yoke valve, an indicating type of control valve used for a fire sprinkler system. Corrosion-resistant sprinkler. A sprinkler fabricated with corrosion-resistant materials or special coatings to be used in an atmosphere that would corrode standard sprinklers. Deficiency. A condition in which the application of the component or systems is not within its design limits or specifications. Deluge valve. A water supply control valve intended to be operated by actuation of an automatic detection system that is installed in the same area as the discharge devices. Each deluge valve is intended to be capable of automatic and manual operation. Deluge sprinkler system. A sprinkler system employing open sprinklers that are attached to a piping system that is connected to a water supply through a valve that is opened by the operation of a detection system installed in the same areas as the sprinklers. When this valve opens, water flows into the piping system and discharges from all sprinklers attached. Dry pipe sprinkler system. A sprinkler system employing automatic sprinklers that are attached to a piping system containing air or nitrogen under pressure. The release of the air or nitrogen, as from the opening of a sprinkler, results in the water pressure opening a valve known as a dry pipe valve, resulting in the flow of water into the piping system and out of the fused sprinklers' heads. Dry sprinkler. A sprinkler secured in an extension nipple that has a seal at the inlet to prevent water from entering the nipple until the sprinkler operates. May be configured with an upright, pendant, or sidewall sprinkler. Discharge device. A device designed to discharge water or foam water solution in a predetermined, fixed, or adjustable pattern. Examples include, but are not limited to, sprinklers, spray nozzles, and hose nozzles. ESFR. Early Suppression Fast Response Sprinkler. A type of fast response sprinkler that is listed for its capability to provide fire suppression of specific high-challenge fire hazards. ELO. Extra large orifice sprinklers. A sprinkler head with an orifice size equal to or greater than 1 inch, particularly for protection of high-piled storage in warehouses unless pressure is required to achieve a given discharge density. Extended coverage sprinklers. A type of spray sprinkler with a maximum area of coverage of 400 square feet, 20 foot by 20 foot spacing between sprinklers, for light hazard occupancies, to a maximum of 144 square feet, 12 foot by 12 foot spacing between sprinklers, for extra hazard occupancies. Fire department connection. A connection, normally on the exterior of the building, through which the fire department can pump supplemental water into the sprinkler system, standpipe, or other system furnishing water for fire extinguishment to supplement existing water supplies, formerly known as Siamese connection. Fire hydrant. A valve connection on a water supply system having one or more outlets, and that is used to supply hose and fire department connections with water. Fire pump. A pump that is a provider of liquid flow and pressure dedicated to fire protection. A fire pump is a part of a fire sprinkler system's water supply and can be powered by electric, diesel, or steam. The pump intake is either connected to the public underground water supply piping or a static water source, examples being a tank, reservoir, or lake. The pump provides water flow at higher pressure to the sprinkler system risers and hose standpipes. Glass bulb sprinkler. A sprinkler operated by heat, breaking a glass bulb filled with a non-freezing liquid with diameters that vary from 3 mm for quick response sprinklers to 5 mm for standard response sprinklers. Hose valve. The valve to an individual hose connection. Hydraulic placard. A sign attached to a hydraulically calculated sprinkler system indicating the design density, required gallons per minute, and pressure for the system to operate properly. Hydraulically calculated systems. A method of sizing automatic sprinkler piping using a prescribed amount of water to be distributed over a specific area. Impairment coordinator. The person responsible for ensuring that proper safety precautions are taken when a fire protection system is placed out of service. Intermediate level sprinkler, rack storage sprinkler. A sprinkler equipped with integral shields to protect the operating element from discharge from sprinklers installed at higher elevations. Large orifice sprinkler. A sprinkler head with an orifice size equal to or greater than 3/4 inch and less than 1 inch. Listed device. A fire protection component that has been tested to perform under parameters specified for its use by a nationally recognized testing agency. Underwriters Laboratory and Factory Mutual are the two most common. Master pressure reducing valve. A pressure-reducing valve installed to regulate pressures in an entire fire protection system and/or standpipe system zone. Main drain. The primary drain connection located on the system riser and also utilized as a flow test connection. MIC. Microbiologically influenced corrosion. Corrosion caused by the presence of microbes in the water supply that over time attack the interior of metallic piping and cause leaks, pitting, and blockages. Out-of-service system. A fire protection system that is not fully functional or whose operation is impaired or is otherwise not in good working order. Old-style/conventional sprinkler. A sprinkler that directs 40% to 60% of the water initially in a downward direction and is designed to be installed with the deflector in either the upright or pendant position. Pendant sprinkler. A sprinkler designed to be installed in such a way that the water stream is directed downward against the deflector. Pintle screws. A visual indicating device required for sprinklers manufactured prior to 1999, identifying small orifice sprinklers and large orifice sprinklers where orifice size is different than the nominal thread size of the sprinkler head. Pipe schedule systems. A method of sizing piping based upon the number of sprinkler heads in the occupancy of the protected area. Pre-action sprinkler system. A sprinkler system employing automatic sprinklers that are attached to a piping system that contains air that may or may not be under pressure, with a supplemental detection system installed in the same areas as the sprinklers. Personal supervision. Supervision by the holder of a FDNY certificate of fitness, who is required to personally present on the premises or other proximate location acceptable to the department while performing the duties for which the certificate is required. Pressure control valve. A pilot-operated pressure-reducing valve that may be used with a fire or booster pump designed for the purpose of preventing the incoming water supply pressure from dropping below a set pressure. Pressure-reducing valve. A valve designed for the purpose of reducing the downstream water pressure under both flowing, residual, and non-flowing static conditions. Pressure relief valve. A valve designed for the purpose of releasing excess air or water pressure from the fire protection piping system. Pressure tank. A tank using air pressure to supplying water for water-based fire protection systems. Tank contents to be maintained at 1/3 air to 2/3 water. Quick response sprinkler head. A sprinkler having a fusible link with a RTI, response time index, of 50 or less. Recessed sprinkler. A sprinkler in which all or part of the body other than the shank thread is mounted above the ceiling. Residential sprinkler. A type of fast response sprinkler that has been specifically tested to enhance survivability in the room of fire origin and listed for use in dwelling units. RTI, response time index, a measurement of the thermal sensitivity of a sprinkler head. SIN, sprinkler identification number. Sprinklers manufactured after January 1, 2000 are required to be marked to identify performance characteristics. Supervisory signal. A signal indicating the need for action in connection with the supervision of guard tours, fire extinguishing systems or equipment, fire alarm systems, or the maintenance features of related systems. Sidewall sprinkler. A sprinkler having special deflectors that are designed to discharge most of the water away from the nearby wall. Small orifice sprinklers. A sprinkler head with an orifice size smaller than 1/2 inch. Solder link sprinkler. A sprinkler operated by the melting of a metal link. They vary in size and configuration for quick response and standard response sprinklers. The smaller the size of the link, the faster the sprinkler operates. Spray sprinkler. A type of sprinkler listed for its capability to provide fire control for a wide range of fire hazards. The most commonly used sprinkler since 1953. Sprinkler system. A fire extinguishing system other than a misfire extinguishing system that utilizes water as the extinguishing agent. Standard response sprinkler head. A sprinkler having a fusible link with a response time index, an RTI of 80 or more. Supervisory signal initiating device. An initiating device, such as a valve supervisory switch, water level indicator, or low air pressure switch on a dry pipe or a pre-action sprinkler system, that triggers a supervisory signal. Testing. A procedure used to determine the status of a system as intended by conducting periodic physical checks on water-based fire protection systems, such as water flow tests, fire pump tests, alarm tests, and trip tests of dry pipe, deluge, or pre-action valves. These tests follow up on the original acceptance test at intervals specified in the appropriate chapter of the NFPA No. 25, 2002 edition. Upright sprinkler. A sprinkler designed to be installed in such a way that the water spray is directed upwards against the deflector. Water spray. Water in a form having a predetermined pattern, particle size, velocity, and density discharge from specially designed nozzles or devices. Water supply. A source of water that provides the flows, expressed as gallons per minute, and pressures, expressed as pounds per square inch, required by the water-based fire protection system. Wet pipe sprinkler system. A sprinkler system employing automatic sprinklers attached to a piping system containing water and connected to a water supply so that water discharges immediately from sprinklers opened by heat from a fire. Water spray fix system. A special fixed pipe system connected to a reliable fire protection water supply and equipped with water spray nozzles for specific water discharge and distribution over the surface or area to be protected. The piping system is connected to the water supply through an automatically or manually actuated valve that initiates the flow of water. An automatic valve is actuated by operation of automatic detection or manual release equipment installed in the same areas as the water spray nozzles. In special cases, the automatic detection system may also be located in another area. Water tank. A tank supplying water for water-based fire protection systems. Chapter 7. System types. Automatic wet sprinkler systems. Automatic sprinkler systems are designed to automatically distribute water on a fire. The sprinkler system is designed to extinguish the fire entirely or to prevent the spread of the fire. An automatic sprinkler system consists of a series of pipes at or near the ceiling in a building. The sprinkler system is fitted with automatic devices designed to release water on a fire. These devices are called sprinkler heads. The sprinkler heads are normally closed by a disc or cap. This cap is held in place by a heat-sensitive releasing element. A rise in temperature to a predetermined level causes the sprinkler head to open. Water is then discharged in the form of spray. When the sprinkler heads open, they are said to have fused. The sprinkler heads are fitted at standard intervals on the piping. If more than one head opens, the area sprayed by each overlaps that of the sprinkler head next to it. Sprinkler systems are required by law in various occupancies. They also may be installed voluntarily by the owner of the building. The sprinklers are installed to protect the building and its residents. The installation of sprinklers has a major effect in reducing fire losses. About 96% of the fires are extinguished or controlled when sprinklers are installed. The 4% failure was due to a variety of causes, including defective piping, closed supply valves, frozen water lines, improper maintenance, and blocked water supply piping. Automatic sprinklers are very effective for life safety. They signal the existence of a fire. At the same time, they discharge water to the burning area. When sprinklers are installed, there are rarely problems getting water to the seat of the fire. They also reduce interference with visibility for firefighting due to smoke. The downward force of the water sprayed from sprinklers lowers the smoke level in the room. The sprinklers also serve to cool the smoke. This makes it possible for persons to remain in the area much longer than they could if the room were without sprinklers. Most standard sprinkler systems have devices that automatically sound an alarm when a sprinkler head discharges water. This alarm is usually an audible signal in the building. In many cases, they also give an alarm at a remote location, such as an approved central station company. The central station company monitors the entire fire protection system for water discharge and problems with the equipment. When water discharge or equipment problems are identified, the local firehouse is immediately notified. This allows the fire department to gain control of a fire as quickly as possible. Water is rarely discharged accidentally from sprinkler heads. The most commonly installed system is wet pipe systems, which have water in the piping at all times. This type of system is used where the temperature is maintained at minimum of 40 degrees to prevent the system from freezing. Where temperatures drop below freezing, the ordinary wet pipe system cannot be used. There are two methods for using automatic sprinklers in places exposed to freezing temperatures. One method is a system where water enters the sprinkler piping only after a control valve is opened. These are dry pipe systems, deluge systems, or pre-action systems. The other method adds an antifreeze solution to the water in the wet pipe system. The antifreeze solution is a mixture of chemicals designed to prevent the water from freezing. Antifreeze solutions. Antifreeze is added to the water and piping exposed to freezing temperatures. When the sprinkler heads fuse, the system works in the same way as a wet pipe system. Antifreeze solutions are costly and may be difficult to maintain. Antifreeze is usually used for small, unheated areas. Antifreeze solutions may be used only in accordance with applicable local health regulations. Existing cold weather valves. An automatic sprinkler system should not be shut off and drained to avoid freezing during cold weather. However, parts of the sprinkler system may be shut down. Permission must be obtained from the local firehouse. Permission may be given to shut off a maximum of 10 sprinkler heads on a wet pipe system. These shut-off valves are commonly referred to as cold weather valves. These valves are no longer permitted to be installed. Automatic dry sprinkler systems. Dry pipe sprinkler systems are installed where a wet pipe system cannot be heated to prevent freezing. Under normal conditions, there is no water in the piping. Instead, the piping in the system is filled with air or nitrogen under pressure. The air pressure in the piping is controlled automatically by an air maintenance device. The system uses standard sprinkler heads. When a sprinkler head is opened by the heat from a fire, the air pressure is reduced in the piping. The drop in air pressure causes a special dry pipe valve to open. A supervisory device signals when the valve is opened. Then water flows into the piping and out of the opened sprinklers. This water flow also sounds a local alarm to alert the people in the building of the fire. The alarm may also be transmitted to a central station company. This station will then notify the fire department that there is a fire. In buildings where life hazard is very high, such as schools and hospitals, the alarm is transmitted directly to the fire department. Sometimes a combination of a wet pipe and a dry pipe system may be used when part of the building cannot be heated. Dry pipe valve designs. These valves prevent water from flowing into the piping until a sprinkler head has opened. The air pressure in the system keeps the clapper closed. This clapper prevents the water from flowing into the system. When the sprinkler head opens, it causes a drop of pressure in the piping. This causes the valve to open and allows water into the system. Most dry pipe valves are designed so that a moderate air pressure in a dry pipe system will hold back a much greater water pressure. When the clapper has opened, the valve is said to have tripped. Higher than normal water pressure, a water hammer, may cause the dry valve to trip by accident. Water hammer is caused by a sudden flow of water or a sudden change of water pressure in the system. To reduce this danger, air pressure is usually kept well above the normal trip point. The air pressure is usually set at 15 to 20 pounds per square inch above the normal trip level. Some valves are specially designed for low pressures. In all cases, the manufacturer's instructions regarding pressures to be maintained shall be followed. Quick opening devices. In a dry pipe system, there is a delay between the opening of a sprinkler and the discharge of water. This delay may allow the fire to spread and more sprinkler heads to open. The delay is due to the time required for the air to leave the sprinkler piping. This difficulty may be partly overcome by the installation of quick opening devices. Two devices are used to reduce the time needed to open the clapper and allow water into the system. These devices are an accelerator and an exhauster. They are both automatically activated when a drop of 2 pounds per square inch in air pressure is detected in the system. They quickly change the water and air pressure balance in the system. This change trips the dry pipe valve, allowing the water to force its way through the sprinkler piping in less time. The failure of an accelerator or exhauster to operate will increase the normal tripping of a dry pipe valve. Pre-action sprinkler systems. Pre-action systems are designed for situations where there is danger of serious water damage. Water damage is usually caused by damaged sprinklers or broken piping. Under normal conditions, there is no water in the piping. The air in the piping may or may not be under pressure. A pre-action valve prevents the water from entering the system. The valve is automatically opened when a fire detection system discovers that there is a fire or smoke condition. The pre-action valve is tripped by the fire detection system before any of the sprinkler heads open. A supervisory device signals when the valve is opened. The pre-action valve can also be operated manually. The pre-action system has several advantages over a dry pipe system. The pre-action valve opens sooner because the fire detectors react to heat changes faster than sprinkler heads. Fire and water damage may be decreased because water is sprayed on the fire more quickly. The alarm signal is given as soon as the pre-action valve is opened. Heat-responsive devices are commonly used to trip pre-action valves. These devices are also used to activate alarm and supervisory systems. There are 3 main devices used to trip pre-action valves. 1. Devices designed to operate at a fixed temperature. 2. Devices designed to operate when the temperature in the room increases a set amount in a given time period, rate of rise, and 3. Devices combining fixed temperature and rate of rise devices. Other ways to activate a pre-action valve are smoke detectors, gas detecting systems, hydraulic, electric, manual release, and automatic signals from other safety systems. Alarms are standard accessory equipment on water control valves. They provide an audible signal in the building if the valve operates for any reason. An alarm is also sent out if a problem is discovered with the equipment. The alarms send a signal to a central station company or a public fire alarm system. Often the signal is sent to both the central station company and the public alarm. Pre-action system with a recycling feature. A special kind of pre-action system is a recycling system for controlling sprinklers. This system shuts off the water when the fire has been put out or the heat drops. If the fire rekindles or the heat rises sharply, water is discharged again. The system continues cycling on and off as long as the fire persists. Combined dry pipe and pre-action systems. These systems have the basic features of both types of systems. The piping system contains air under pressure. A heat detecting device opens the water control valve and a quick opening device. The system then fills with water and operates as a wet pipe system. If the heat detecting system fails, the system will operate as a standard dry pipe system. Deluge sprinkler systems. A deluge sprinkler system is equipped with open sprinkler heads designed to wet down an entire area involved in a fire. This system is needed when there is danger of a fire rapidly spreading throughout the building. The deluge system will slow down the spread of the fire. Deluge systems are suitable for hazardous occupancies. This includes buildings in which flammable liquids or other hazardous materials are handled or stored. The sprinkler heads in the deluge system are open at all times. Under normal conditions, there is no water in the piping. The air in the piping is not under pressure. A closed control valve prevents water from flowing into the system. A fire detection device automatically opens the control valve when a fire is identified. A supervisory device signals when the valve is opened. When the valve is opened, water flows into the system. The water is then discharged out all of the sprinkler heads. The water control valve may also be opened manually. Non-automatic dry sprinkler systems. In this type of system, all pipes are normally dry. Water is supplied when needed by pumping water into the system through the fire department connection. Some of these systems are supplied by manual operation of a water control valve and may be equipped with sprinklers with or without fusible links. There are several non-automatic systems. 1. Perforated pipe systems, a single line of piping drilled at intervals for water discharge. These systems are usually found in basements or other areas difficult to reach in firefighting operations. 2. Open fixed spray nozzles for transformer vaults or other hazardous areas. 3. Exterior exposure sprinklers or window sprinklers use open sprinkler heads to form an external water curtain on the walls of a building. And 4. Foam supply systems are used for the protection of special hazardous occupancies. Garbage compactor sprinkler systems. Waste compactors are usually found in tall, multiple dwelling complexes, such as apartment buildings. They are used to reduce the trash buildup in a building. They consist of a tall chute with an opening at each floor. These openings are used for trash disposal. Occupants of the buildings take their trash and throw it through the opening and down the chute. The trash piles up at the bottom of the chute, where a device regularly crushes the trash into smaller blocks of trash. The blocks of trash are then removed and taken to a garbage dump. The compactor may be located indoors or outdoors. The buildup of trash in the compactor chute is a fire hazard. Fires may be started in several ways, for example, by a smoldering cigarette thrown into the compactor chute. Sprinkler systems must be installed to put out fires that start in the compactor chute. Any of the standard water supply sources may be used to supply the compactor sprinkler system. For example, gravity tanks, fire pumps, and pressure tanks are all used as water supply sources. Fire doors shall be installed in the chute to allow firefighter access to burning trash. The certificate of fitness holder shall know the location of all sprinkler heads, control valves, supply lines, and compactor rooms. A sketch of the entire compactor sprinkler system shall be drawn by the certificate of fitness holder. This sketch shall be posted in the compactor room, in a frame under glass. The sketch shall be made available to any representatives from the fire department. The certificate of fitness holder may be questioned about this sketch by inspectors from the fire department during routine inspections. A sign indicating the location of all control valves shall be kept in the compactor room. This sign shall be displayed with the sketch in the compactor room. All control valves in the sprinkler system shall be labeled. The label is to show the purpose of the valve. Additionally, the labels shall be attached to the yoke of the valves. All indicating valves in the compactor sprinkler system shall be sealed open. A minimum of 6 extra sprinkler heads with the appropriate wrenches shall be available to replace any opened or damaged sprinkler heads. Opened or damaged sprinkler heads shall be replaced immediately. A garden hose connected to a water supply shall be kept in the compactor room. This hose may be used to put out small fires or smoldering material in the compactor room. This certificate of fitness holder shall conduct an inspection of the entire sprinkler system at least once a month. Special attention should be given to the condition of the sprinkler heads in the compactor chute and the compactor room. Any defects or violations shall be recorded in a detailed inspection report. All inspections are recorded on a card that shall be kept near the main control valve. The certificate of fitness holder shall sign and date the card each time an inspection is made. If any minor defects in the system are discovered, they shall be reported to the owner of the building. If repairs are not made within 30 days, the certificate of fitness holder must notify the Bureau of Fire Prevention. If any major defects are discovered, they shall be reported to the FDNY dispatcher, the owner of the building, and the Bureau of Fire Prevention. Major defects shall be repaired immediately. When a fire is discovered in the compactor, the certificate of fitness holder should notify the local firehouse immediately and should not attempt to enter the compactor chute to put out the fire. Chapter 8. Water supplies for sprinkler systems. The sources used to supply water to sprinkler systems are the same as those for standpipe systems. Sprinklers may be supplied from one or a combination of sources. For example, they may be supplied by public mains, gravity tanks, pressure tanks, fire pumps, reservoirs, rivers, or lakes. A single water supply would appear to be all that is needed to supply a sprinkler fire protection system. This assumes that there is enough water at an acceptable pressure. However, a single supply may be out of service for maintenance or repair during a fire emergency, or it may be disabled during a fire or before the fire is fully extinguished. Additionally, the water supply may fall below normal pressure or volume during an emergency. These are just a few reasons why it is good to have a secondary water supply. In some cases, it is required by law to have a secondary water supply source. Whether a second source is needed depends on several factors. These factors include the strength and reliability of the primary supply, the value of the property, the height, area, occupancy classification, and design of the building. When a sprinkler system is supplied from a public water main, the entire system shall be shut down by closing a non-indicating type control valve. This valve is located between the building and the water main in a box that is recessed into the sidewalk. The location of the box is found by reading a sign on the building or on a post nearby. The sign might read, "Shut off for sprinkler system located 6 feet from this sign," or it may have similar instructions. A special key will be required to operate this valve. Curb valves. Gate valves of the non-indicating type are provided in water distribution systems. Gate valves allow the sprinkler system to be shut off for repairs or maintenance. Such valves are normally a non-rising stem type. They are operated using a special key wrench. A valve box is located over the valve to keep dirt from the valve. The valve box also provides a convenient access point for the valve wrench to the valve nut. A complete record should be made for each valve in the system. This record should include the exact location, the date it was installed, the make, the direction of opening, number of turns to open, and any maintenance that was performed. The control valve for the building may also be on the outside wall or attached to an upright post, known as a post indicator valve or PIV. The building or section of the building controlled by the valve is usually marked on the post. The position of this valve, open or closed, is shown through a telltale opening in the post. On some posts, a padlock must first be opened to release the operating wrench or wheel handle. The main water supply for sprinklers may also be controlled by an S-Y, outside stem and yoke valve. The valves are found just inside the building wall on the main riser, or outside in protected pits. It is easy to tell at a glance if the valve is open or shut. When the stem is all the way out, the valve is open. When the stem is all the way in, the valve is closed. Approved indicator valves use a flag that shows the valve position, and the valves commonly are used to control the water supply for individual floors in a building. Indication control valves are also installed to shut off certain sections of an individual floor. Being able to shut off parts of a building allows the fire department to have greater control over the sprinkler system. When a fire is under control in an area, the S-Y valve can be closed to prevent any further water damage. Sometimes repairs must be made to the sprinkler system. When this occurs, the indicating control valves are used to close the water supply to only those sections being repaired. This is good safeguard since the rest of the sprinkler system does not have to be shut down. Pumper connections for fire department use. Normally, a sprinkler system is connected to an automatic water supply source. Auxiliary sources of water are supplied through fire department connections at the building. Fire department connections are a standard part of most sprinkler systems. When responding to an alarm, most fire departments supply water to the standpipe system first. The standpipe system supplies water to the fire hoses to be used within the building. Water is then supplied to the sprinkler system through its own fire department connection. Care should be taken that the standpipe and the sprinkler connections are properly marked because the connections look the same. The exact purpose of each fire department connection should be shown nearby or on the fire department connection itself. The New York City Building Code requires fire department connections to be color-coded. The fire department connection to an automatic sprinkler system shall be painted green. The fire department connection to non-automatic sprinkler system shall be painted silver. The fire department connection to a standpipe system shall be painted red. Local Law 58/2009 requires color coding of fire standpipe and fire sprinkler systems to have the risers, cross connections to the water supply piping painted red. The fire department connection to a combined standpipe/sprinkler system shall be painted yellow. Fire department connections must always be accessible. Each connection shall be fitted with a lower check valve. The lower check valve prevents the backflow of the private water supply into the fire department connection. The automatic ball drip device between the lower check valve and the outside fire department water from building up in the piping and shall be installed in the horizontal position. This ball drip device makes sure that the fire department connection is not blocked by water which has frozen within the piping. If water freezes in the piping, the fire department will not be able to pump water into the system. Gravity tanks. Gravity tanks of adequate capacity and elevation make a good primary supply and may be acceptable as a single supply. A gravity tank may be located on the top of a building or on a tall tower. The water in the tank is distributed throughout the sprinkler system because of the pull of gravity. Pressure tanks. Pressure tanks have several possible uses in automatic sprinkler fire protection systems. The tank is normally kept at 2/3 full of water and 1/3 full of air. The air pressure in the tank shall be maintained at or above 75 psi. Air for pressure tanks is supplied by air compressors. Because the water is always under pressure, it can be forcefully distributed throughout the sprinkler system. An important limitation is the small amount of water that can be stored in such tanks. Where a small pressure tank is accepted as the water supply, the system is called a limited supply system. Pressure tanks are often used in situations where an adequate amount of water can be supplied by a public or private source, but the water pressure is not adequate. The pressure tank gives a strong starting pressure for the first sprinklers that open. The flow from the tank may be used while the automatic fire pumps begin to increase the water supply pressure. Pressure tanks are often used in tall buildings that need extra water pressure to supply the highest line of sprinkler heads. The pressure tank supplies these sprinkler heads until the fire department begins pumping water into the sprinkler system. Fire pumps. Fire pumps can be used as a main water supply source for sprinkler systems. They may also be used in combination with gravity tanks to supply sprinkler systems. Fire pumps are designed to take the water from a supply source and then discharge the water into the fire protection system under pressure. The amount of pressure with which the water is discharged from the pump is called the total head. The total head is measured in pounds per square inch. The higher the PSI rating of the pump, the greater the pressure with which the water can be discharged. Fire pumps shall be sized to satisfy the hydraulic requirements of the sprinkler system. A fire pump having both a reliable source of power and a reliable suction water supply is an effective piece of equipment. A suction water supply is simply a body of water that the pump can draw water from. Fire pumps are commonly used because they can pump water into the sprinkler system under high pressure. With a good water supply, a fire pump can pump water into a sprinkler system for a long time. Manually started pumps may be used as a secondary supply source if the primary water supply will last long enough to allow the pump to be started. This type of system gives an automatic water flow signal to the certificate of fitness holder when the pump must be started. Automatic fire pumps are usually needed where a high water demand may occur immediately. This demand may occur in a deluge system. The automatic fire pump is also used when someone is not always present to activate a manual pump. Automatic fire pumps must have their suction under a positive head to avoid the delays of drawing water from a supply source. Under positive head simply means that the water supplying the pump must be fed into the fire pump under pressure. This can be achieved by connecting the fire pump to a suction tank. Water is forced into the pump because of gravity. Chapter 9. Water flow alarms and sprinkler system supervision. Sprinkler systems should have devices and equipment for signaling when water flows through risers or mains supplying the systems. The flow may be due to fire, leakage, or accidental rupture of the piping. It is important that prompt action is taken when water flow is signaled by these devices. Functions of alarms and supervisory signals. A sprinkler system with a water alarm serves two functions. 1. It is an effective fire extinguishing system, and 2. It is an automatic fire alarm. An alarm is signaled as soon as the sprinkler head is opened. This is important since it allows the occupants time to leave the building. It also signals that the fire department should be summoned. Water flow alarms and fire alarms give warning of the actual occurrence of a fire. They also signal when water flows through the system due to broken pipes. Alarms alert occupants and summon the fire department. Any signal, whether water flow or supervisory, may be used to sound an audible local sprinkler alarm. It may also send a signal to the central station company. The central station company will then contact the local firehouse. Supervisory devices are often connected to an approved central station company which monitors the sprinkler system for problems with equipment and when sprinkler heads are opened. The central station company should be notified when any control valves are closed for maintenance or repair. This reduces the number of false alarms. Sprinkler systems are required to have an approved water motor gong or an electric bell, horn, or siren on the outside of the building. An electric bell or other audible signal device may also be located inside the building. Water-operated devices must be located near the alarm valve, dry pipe valve, or other water control valves in order to avoid long runs of connecting pipe. Devices and equipment supervised. Sprinkler system supervision is commonly provided for several purposes. They are used to supervise. 1. Water supply control valves. 2. Low water level in water supply tanks. 3. Low temperature in water supply tanks or ground level reservoirs. 4. High or low water level in pressure tanks. 5. High or low air pressure in pressure tanks. 6. High or low air pressure in dry pipe sprinkler systems. 7. Failure of electric power supply to fire pumps. And 8. Automatic operation of electric fire pumps. Water flow alarm valves. The basic design of most water flow alarm valves is that of a check valve, which lifts from its seat when water flows into a sprinkler system. This alarm then starts an audible signal to alert the occupants in the building that the sprinkler system has been activated. Vane-type water flow. Switches have a paddle inserted inside the main supply piping perpendicular to the direction of flow. Upon water flow, the paddle switch transmits an alarm. Vane-type water flow switches cannot be installed to monitor water flow in dry pipe sprinkler systems. Alarm retarding devices. An alarm check valve that is exposed to changing water supply pressure needs an alarm retarding device. This is required to prevent false alarms when the check valve clapper is lifted from its seat by a temporary pressure surge. Vane-type water flow switches sensitivity can also be adjusted to changing water pressures. Chapter 10. System components. Sprinkler heads. Sprinkler heads are made of metal. They are screwed into the piping at standard intervals. The water is prevented from leaving the sprinkler head by an arrangement of levers and links. The levers and links are soldered together on the sprinkler head. The solder is a metal alloy with a fixed melting point. Other types of sprinkler heads use a glass bulb which expands and breaks under heat. The sprinkler head is factory tested to withstand at least 400 psi without injury or leakage. If properly installed, there is little danger of the sprinkler operating unless it is damaged. There are over 50,000 different variations of sprinkler heads. Sprinklers manufactured after January 1, 2000 are required to have an SIN or Sprinkler Identification Number. Sprinkler heads manufactured prior shall be replaced as required with sprinkler heads of similar characteristics such as orifice size, temperature rating, and deflector orientation. Recalled sprinkler heads. A sprinkler head that has been recalled is called the cycling sprinkler. This sprinkler cycles water on and off depending on the temperature. When the disc reaches a temperature of 165 degrees Fahrenheit, the valve opens, permitting water to flow. When the disc temperature cools, the valve closes to shut off the water. These sprinklers and others listed for recall are subject to replacement, can be found at www.cpsc.gov. Some sprinkler heads are designed to be used in special situations. Sprinkler heads exposed to corrosive conditions are often covered with a protective coat of wax or lead. Corrosive vapors are likely to make automatic sprinklers inoperative or slow down the speed of operation. They can also seriously block the spray nozzles in the sprinkler heads. They can damage weaken or destroy the delicate parts of the sprinkler heads. In most cases, such corrosive action takes place over a long time. For this reason, the sprinkler heads must be carefully watched for signs of corrosion. Care should be taken to make sure that the protective coating is not damaged when handling or replacing the heads. Spray pattern of sprinkler heads. The best way to put out a fire is to spray the water from the sprinkler head downward and horizontally. The spray pattern will also prevent the spread of the fire. The force of the water against the deflector creates a heavy spray which is directed outward and downward. The shape of the deflector determines the spray pattern of the water discharged from the sprinkler head. Usually, this is an umbrella-shaped spray pattern. At a distance of 4 feet below the deflector, the spray covers a circular area having a diameter of approximately 16 feet when the sprinkler is discharging 15 gallons per minute. Sprinkler spray patterns must not be obstructed by building components or storage. Systems using large drop sprinkler heads. Large drop sprinkler heads are special sprinklers designed to discharge large drops of water from the head. These sprinkler heads are used to break through the strong updrafts of high-challenge fires. The temperature ratings classifications and color coding chart will be provided when taking this test, but it is important to cover. Sprinklers shall have their frame arms, deflector, coating material, or liquid bulb colored in according to the following table. Temperature ratings classifications and color coding. For a maximum ceiling temperature of 100 degrees Fahrenheit, with a temperature rating of 135 to 170 degrees Fahrenheit, and a temperature classification of ordinary, with a frame color code of uncolored or black. The glass bulb colors would be orange or red. For a maximum ceiling temperature of 150 degrees Fahrenheit, with a temperature rating of 175 to 225 degrees Fahrenheit, and a temperature classification of intermediate, with a frame color code of white, the glass bulb colors would be yellow or green. For a maximum ceiling temperature of 225 degrees Fahrenheit, with a temperature rating of 250 to 300 degrees Fahrenheit, and a temperature classification of high, with a frame color code of blue, the glass bulb color would be blue. For a maximum ceiling temperature of 300 degrees Fahrenheit, with a temperature rating of 325 to 375 degrees Fahrenheit, and a temperature classification of extra high, with a frame color code of red, the glass bulb color would be purple. For a maximum ceiling temperature of 375 degrees Fahrenheit, with a temperature rating of 400 to 475 degrees Fahrenheit, and a temperature classification of very extra high, with a frame color code of green, the glass bulb color would be black. For a maximum ceiling temperature of 475 degrees Fahrenheit, with a temperature rating of 500 to 575 degrees Fahrenheit, and a temperature classification of ultra high, with a frame color code of orange, the glass bulb color would also be black. For a maximum ceiling temperature of 625 degrees Fahrenheit, with a temperature rating of 650 degrees Fahrenheit, and a temperature classification also of ultra high, with a frame color code of orange, the glass bulb color would also be black. See page 28 in the New York Fire Department transcript for a printable chart. It is highly recommended that you print out a physical copy of the chart to use when taking the practice exams. Replicating as much of the actual exam materials as possible will better prepare you for the test and will ensure that you can complete the exam in the allotted time. In places where the temperature is normally high, such as boilers, ovens, and drying rooms, a sprinkler head with a higher temperature rating must be used. This is to make sure that the sprinkler head does not discharge water at the wrong time. If heads with a high temperature rating are used in an ordinary room, like an office, an apartment, and store, the value of the sprinkler protection is greatly reduced. This is because the temperature will have to increase much higher for the sprinkler heads to open. Sprinkler systems are excellent for controlling fires. However, they can cause water damage if they are not shut down soon after the fire has been extinguished. No control valve on the system should be closed except on the order of the fire officer in charge. If the fire has been completely extinguished, the building owner or their representative may close the control valve. Sometimes the fire department has a difficult time finding the control valve to shut down the system. This problem can be prevented by keeping a small sketch of the sprinkler system and the position of the control valves. This sketch should always be readily available. This sketch is very helpful to the firefighters when they have to work with the sprinkler system. Buildup of foreign material on sprinklers. Sometimes conditions exist which cause a buildup of foreign material on sprinkler heads. This may prevent the sprinkler head from working properly. This buildup is commonly called loading. The buildup of foreign material insulates the sprinkler head. This buildup prevents the sprinkler from opening at the desired temperature. If the buildup is hard, it may prevent the sprinkler from opening. Replace loaded sprinkler heads with new sprinkler heads rather than attempting to clean them. If the deposits are hard, attempts to clean the heads are likely to damage them. This damage may prevent the sprinkler heads from working properly. The damage may also cause the sprinkler head to leak. Deposits of light dust are less serious than hard deposits. Dust buildup may delay the operation of sprinkler heads. However, it will not prevent the eventual discharge of water. Dust deposits can be blown or brushed off. If a brush is used, it should be soft to avoid possible injury to sprinkler parts. Scouring or acidic liquids are likely to damage the sprinkler heads and should not be used for cleaning. Hot solutions of any kind should never be used to clean the sprinkler heads. Removal of protective caps and straps on glass bulb sprinklers shall be performed at the time of installation. Spare sprinkler heads. Sprinklers required for emergency replacement must be representative of the type of sprinklers installed along with the proper wrenches. These wrenches shall be provided in the spare head cabinet. It is critical sprinklers be replaced with devices that will perform similarly to the original system sprinklers. Sprinklers that are replaced during an emergency by unlicensed individuals require that the devices used have been verified appropriate for the protected area by a master fire suppression piping contractor. After activation by fire, sprinklers in close proximity to the affected heads are recommended to be replaced. A stock of spare sprinklers, not less than 6, shall be kept on the premise where the temperature does not exceed 100 degrees Fahrenheit, and shall include all types and ratings installed in the protected facility and provided as follows. Under 300 sprinklers, 6 spares are required. For 301 to 1,000 sprinklers, 12 spares are required. If there are over 1,000 sprinklers, 24 spares are required. Pressure tanks. Pressure tanks are enclosed water tanks of limited size. Air pressure in the tank permits forceful discharge of water in the tank into the sprinkler system. A pressure tank may be used as a primary or secondary water supply for a sprinkler system. A pressure tank is usually housed in an enclosed structure. The temperature in the enclosure is kept at 40 degrees Fahrenheit or above. The heated structure may be located anywhere in the side or even outside of the building. Pressure tanks are to be maintained at approximately 2/3 full of water and 1/3 full of pressurized air. The minimum acceptable air pressure inside the tank is 75 psi. The air pressure in the tank is automatically maintained by an air compressor. The maximum gross capacity of pressure tanks is 9,000 gallons. Some sprinkler systems require more than 6,000 gallons of water. When this occurs, several pressure tanks are used in combination to supply the system. Standard pressure tank. Pressure tank alarms. All pressure tanks used to provide the required primary water supply for a sprinkler system shall be equipped with 2 high and low alarm systems. One system monitors the high and low air pressure. The other system monitors the high and low water levels. The alarm system automatically monitors the air-to-water volume ratio, which should always be 1 air to 2 water. An alarm signals the certificate of fitness holder or central station operator when the water level or the air pressure falls too high or too low. When this occurs, the pressure tanks should be adjusted or repaired immediately. Supervision of the pressure tank. The pressure tank may also be supervised by an approved central station company which monitors the entire sprinkler system. Supervisory devices are installed in the pressure tank. These devices alert the central station company when there is a problem with the tank's water level, air pressure, and water temperature. The devices also alert the central station company when water has been discharged from the tank. When sprinkler heads have fused and water has been discharged from the tank, the local firehouse is notified. The central station company notifies the certificate of fitness holder when a problem is caused by equipment failure. Repairs and adjustments shall be made quickly to return the pressure tank to good working order. Gravity tanks. Gravity tanks are used for water storage. They are made of wood, steel, or concrete. Gravity tanks are used as a primary or secondary water supply source for sprinkler systems. A gravity tank system delivers water from the tank through the sprinkler system without the use of pumping equipment. A gravity tank should be at least 25 feet above the highest line of sprinkler heads that it supplies. Tanks may be located on the tops of buildings or raised on tall supporting towers. The water pressure in a gravity tank system depends on the elevation of the tank. This is the main advantage over other kinds of systems. For every 1 foot the tank is above the discharge outlet, 0.433 pounds per square inch of water pressure is generated. In other words, the higher the tank elevation, the greater the water pressure. The gravity tank is extremely reliable. It does not depend on the operation of mechanical equipment to supply the sprinkler system. Automatic fill pumps supply the water to most gravity tanks. The pumps fill the tank at a rate of 65 gallons per minute or more. The floats turn on the fill pump when the water in the tank is too low. The floats shut off the pump when the desired water level is reached. The floats make sure the gravity tank always has the right amount of water to supply the sprinkler system. All gravity tanks have an overflow pipe that drains off excess water in the tank. This happens if the floats do not turn off the fill pump. A fill pump is not necessary if the water pressure in the city water main is able to keep the tank filled with the correct amount of water. Gravity tanks are exposed to very low temperatures. All parts of the gravity tank must be insulated or heated to keep the water from freezing. Several methods are used to heat the tank and the pipe that supplies the water. 1. Hot water is circulated by gravity. 2. Steam is discharged directly into the tank. 3. Steam coils are placed inside the tanks. 4. Heat from the sun is used. The certificate of fitness holder can find out the temperature of the water by using a thermometer. The thermometer is located near the heating device. Severe damage can occur to the piping and the tank if the water inside the tank freezes. During freezing weather, the temperature of the water inside the tank and the riser must be checked daily. The temperature of the water shall always be at least 40 degrees Fahrenheit. Ice should not be allowed to build up on the gravity tank. The extra weight of the ice might weaken the supports of the tank and cause the tank to collapse. Falling icicles may also cause damage or injury. It is essential to be sure that the tank is properly heated, insulated, and carefully maintained. The gravity tank must always have a full supply of water. A full tank of water is needed to ensure the sprinkler system works properly during a fire. Keeping the tank full of water also prevents wooden tanks from shrinking. A full tank of water helps keep steel tanks from rusting. Gravity tank supervision. The gravity tank shall be constantly monitored to ensure that the tank and its parts are working. Electrical supervision devices monitor the water temperature and the water level in the gravity tank. These devices send signals to an approved central station company about the water level and water temperature. The central station company notifies the certificate of fitness holder when a problem with the gravity tank is detected. The certificate of fitness holder shall correct the problem as soon as possible. The supervisory devices are sometimes called high and low alarms, since they also send audible signals to alert the certificate of fitness holder or central station when there is a problem. The main reason a sprinkler system supplied by a gravity tank fails during a fire is not enough water in the tank. The sprinkler system cannot be supplied if there is not enough water in the tank. A proper water level shall be maintained. The centrifugal pump. The centrifugal fire pump is the standard pump currently used in fire protection systems. This is the preferred pump because it is reliable, compact, requires low maintenance, and it can be powered by a variety of drivers including electric motors, internal combustion engines, and steam turbines. Principle of operation. The water available to the centrifugal pump must always be under pressure because the pump cannot lift water for the supply source. A water tank can be used if the tank supplies the pump due to gravity. In other words, the weight of the water forces the water to flow into the pump. This type of water tank is called a suction tank. The water flows from the tank through the supply inlet into the pump. As the water passes to the center of the pump, it reaches a rotating impeller. This impeller is designed to grab the water on the inlet side of the pump and then discharge the water under increased pressure into the fire protection system. Depending on the model, centrifugal pumps are capable of discharging water from 25 gallons per minute up to 5,000 gallons per minute. Most centrifugal pumps have a single impeller and are therefore commonly called single-stage fire pumps. The vertical turbine pump. A vertical turbine pump is really a modified centrifugal pump that has the capability to draw water from streams, ponds, and wells. Unlike the standard centrifugal pump, the vertical turbine pump does not need the suction supply to be under pressure for it to operate. Instead, it draws the water into the pump by suction. When it reaches the rotating impellers, the water pressure is increased and then forcefully discharged into the fire protection system. Although the vertical turbine pump is capable of drawing water from wells, it is generally not recommended to use a well as the main water supply source because it may dry up without warning. Should the well dry up, it would make the turbine pump useless. It is better to draw water from the well and to fill a water storage tank. A fire pump should then be attached to a more reliable supply source, such as a storage or a suction tank. When using a pump to draw water from a suction supply source, it is important to ensure the water intake hose, foot valve, and screens are inspected regularly. Mud, gravel, and leaves may cause damage to the pump or obstruct the sprinkler system piping. Pump activation. A fire pump can be started automatically or manually. The pump can be started automatically by an electric controller or an engine controller. These controllers activate the pump when there is a drop of water pressure or water flow in the fire protection system. The controllers are adjusted so that a minor drop in water pressure or minor increase in water flow due to a small leak will not activate the pumps. The controllers for the fire pumps are expensive, require extensive maintenance and periodic testing. Where an electric motor drive is used, a standby power generator is sometimes required. If an engine controller is used, the appropriate fuel storage tanks should be filled and checked regularly. When manually activated pumps are installed, they are usually used in combination with a gravity tank or a pressure tank. These tanks are designed to operate when there is a pressure drop in the fire protection system. The operation of the pressure tank and the triggering of its supervisory devices, or alarms, alert the certificate of fitness holder that the fire pump must be activated. The certificate of fitness holder, or another responsible individual, should then manually activate the fire pump according to the manufacturer instructions. Manually operated fire pumps are often found in industrial and manufacturing occupancies having personnel on the premises at all times. The certificate of fitness holder may only activate a manually operated vertical fire pump arranged as described above. Sometimes remote push buttons are used to activate the pump. These remote push buttons are designed to start the pump but not to stop the fire pump. Pressure maintenance pumps or jockey pumps. Pressure maintenance pumps, sometimes referred to as jockey or makeup pumps, are often found on sprinkler systems. These pumps are designed to automatically operate when there is a slight drop in pressure due to the leakage in the system or a pressure surge. The jockey pump restores the pressure in the fire protection system to the desired level. When the drop of pressure in the system is greater than the capacity of the jockey pump, the fire pump is activated. Booster pumps / special service pumps. Booster pumps are sometimes used in sprinkler systems. These small pumps with limited power are usually located in the basement or taking suction from gravity tanks. The booster pump is used when the water pressure available at the highest sprinkler head does not quite meet the needs of the sprinkler system. This small pump increases the water pressure in the sprinkler system until it reaches acceptable levels. The booster pump should not be confused with the fire pump or the jockey pump. Operation and supervision. When fire pumps are activated by electric automatic controllers, it is essential that they are constantly monitored to ensure the availability of the electrical power supply in case of an emergency. For this reason, supervisory devices are installed on the pumps to alert the certificate of fitness holder and/or a central monitoring station when there is an electrical power failure. In cases where steam turbines or internal combustion engines are used, similar supervisory devices are installed to signal when there is a problem with the controlling equipment. Fire pump location. The fire pump should be housed in a room that is fire-resistant or constructed of non-combustible material. The pump room should be located as close as possible to the fire protection system. The pump room should be kept clean and accessible at all times. The fire pump, driver, and controller should be protected against possible interruption of service. The temperature inside the pump room should be maintained above 40 degrees Fahrenheit at all times to prevent freezing of the water. The pump room should only be used for fire protection functions and not for general plant operations. No storage is permitted in this room. Chapter 11. Hanging, bracing, and restraint of sprinkler system piping. The structural support of the sprinkler system plays an integral part of system reliability. Missing or defective pipe hangers can cause the entire system to fail from pipe rupturing or leaking. Great care and experience must be applied when evaluating the adequacy of the structural support of the system. Piping shall be supported from the building structure in accordance with the New York City Code requirements and National Fire Protection Association No. 13, 2002 edition. The annual visual inspection of system hanging components and bracing is the most complicated and difficult of all the tasks to be performed by the certificate of fitness holder. This reference is a starting point, and by no means does it fully explain the various means, methods, and requirements to adequately perform this annual inspection task. Chapter 9 of the NFPA No. 13, 2002 edition describes in great detail the fundamentals of hanger design and installation and should be used as a reference guide for accurate inspection results that will be reported to the owner and the FDNY. There are any number of different deficiencies that may be found during the inspection process. They may include system supports being disturbed by the movement of adjacent equipment, deflection or sagging of the building structure, deterioration of the portion of the structure used to support the system, and attaching excessive loads to hanging components or piping. Unapproved or makeshift hangers, such as perforated strapping or baling wire, are prohibited. Nails shall not be used to fasten the system or building attachments to the structure. Hangers used with plastic piping must be listed for use with the piping material. A visual inspection of the system is performed from the floor to determine if the hangers, bracing, and restraints are in place and if the piping has moved from its original location and position. This can be observed if the hanger rods or piping attachments are not being supported adequately from the building, bent, misaligned, loose, or missing. Shifting of the system may occur during pressure surges, water hammering, alterations, testing, or operation. The visual inspection of hanging and bracing for sprinkler systems is not required for piping concealed by building construction above ceilings and in concealed spaces. When there is an indication of concealed piping system sprinklers heads either too far above or below a hung ceiling, further investigation is required to determine if hangers and supports are defective or missing. No other components shall be supported using the sprinkler system piping or hanger assemblies supporting the system. There are many variations in hanger assemblies. See pages 37 through 41 of the FDNY transcript for a visual reference of 52 hardware components used throughout the industry. A brief overview of piping and support fundamentals. Sprinkler system piping is categorized as follows. Branch lines are directly connected to sprinkler heads. Cross mains or loop mains are directly connected to branch lines. Feed mains are directly connected to cross mains or loop mains. Risers are able to supply feed mains or cross mains directly. The spacing of hangers varies with the material and diameter of the piping, the location of piping connections, ability of the structure to support the piping, the location of the piping in relation to the building structure, and the system attachments. Hangers generally consist of an attachment to the piping, an attachment to the building structure, and a ferrous rod attaching the components together. Hanging components are generally required to be listed devices. However, a licensed professional engineer may also certify that a hanger or hanging assembly may be used. A partial list of specific hanger spacing requirements. Standard wall steel pipe with diameters 1 inch and 1 1/4 inch are required to have hangers placed at a maximum of 12 feet apart. For all other pipe diameters, the maximum distance between hangers is 15 feet. The maximum hanger spacing for threaded light wall steel pipe shall not exceed 12 feet apart. The maximum hanger spacing for CPVC, plastic pipe, varies from a maximum 5 feet 6 inches for 3/4 inch piping to a maximum 10 feet on center for 3 inch piping. There are extensive additional hangings and bracing requirements for CPVC piping, and the installation and design manuals for this product must be referenced to perform adequate visual inspections required by the standard. The distance for the hanger assembly to the center line of an upright sprinkler head shall not be less than 3 inches. Hangers placed closer to sprinklers will cause an obstruction to the discharge pattern. For systems operating at less than 100 psi, the unsupported length between the end sprinkler head and the last hanger on the line shall not exceed 36 inches for 1 inch piping, 48 inches for 1 1/4 inch piping, and 60 inches for piping 1 1/2 inch or larger. For systems operating at pressures of 100 psi or greater, the hanger closest to the last sprinkler on the line shall be of the type that prevents the upward movement of the piping within the hanger assembly. This can be accomplished by the use of a surge restrainer. The cumulative length of an unsupported arm over to a sprinkler head, sprinkler drop, or sprinkler sprig up shall not exceed 24 inches for steel pipe and 12 inches for copper pipe. System risers, vertical piping passing from floor to floor, shall be supported with riser clamps and hangers located within 24 inches of the center line of the riser. The distance between supports for risers shall not exceed 25 feet. The minimum size hanger rods are required as follows. For up to and including 4-inch pipe, a 3/8 inch rod is required. For 5, 6, and 8-inch pipe, a 1/2 inch rod is required. For 10 and 12-inch pipe, a 5/8 inch rod is required. Seismic restraints. The New York City Building Code adopted earthquake code requirements. This reclassification requires the installation of sway bracing for earthquake protection be installed on sprinkler systems in buildings built after 1998. The system piping shall be braced to resist both lateral and longitudinal horizontal seismic loads and to prevent vertical motion resulting from seismic events. Lateral braces shall be spaced at a maximum of 40 feet on centers and are required on all piping 2.5 inch and larger. The distance from the last brace to the end of the pipe being braced shall not exceed 20 feet. Longitudinal braces shall be spaced at a maximum of 80 feet on centers and are to be provided on feed and cross mains. Piping shall be protected against damage where subject to earthquakes by the use of flexible couplings for piping 2.5 inch and larger. Flexible connection shall also be provided at building expansion joints and within 24 inches of top and bottom of the piping dropping down to in-rack sprinklers and mezzanines regardless of pipe size. To avoid damage to piping passing through holes in platforms, walls, floors, and foundations, a clearance of at least 2 inches shall be provided around the piping and the penetration. If this is not provided, a flexible coupling shall be provided within 1 foot on both sides of the wall, floor, beam openings, or platforms. Risers exceeding 3 feet in length shall be equipped with a 4-way brace with distances between braces not to exceed 25 feet. All parts of bracing and fittings attaching bracing to the piping shall lie in a straight line to avoid uneven loading of fittings and fasteners. Refer to page 43 of the FDNY transcript for visual examples of various seismic restraints. Chapter 12. Maintenance, Testing and inspection frequencies. Inspection and maintenance of pressure tanks. The water level and air pressure in pressure tanks shall be inspected monthly and maintained in accordance with the National Fire Protection Association, number 25, 2002 edition. The water level and air pressure must provide an adequate water supply to the sprinkler system. The capacity of the compressor shall be sufficient to build up the tank pressure to 75 psi within 3 hours or less. The water gauge valve shall be opened to examine the water level. When the valve is opened, the water will flow into the gauge. This allows the certificate of fitness holder to compare the water level in the tank to the desired water level mark. Adjustments to the water level should be made as needed. After visually inspecting the water gauge valve, the valve should be closed. When the valve is closed, the water and air in the tank are isolated from the sight glass. If the gauge glass breaks, the volume of water and the air pressure will not be affected. The inside of pressure tanks shall be inspected carefully every 3 years. Rusting in the tank may require repainting or other repairs. The inside of the tank should be thoroughly scraped, wire brushed, and repainted. No foreign materials should be allowed to fall into the sprinkler system. The temperature inside the structure housing the pressure tank should be checked daily during cold weather to make sure that the temperature is at least 40 degrees Fahrenheit at all times. Inspection and maintenance of the gravity tank. The gravity tank should be regularly inspected and maintained in accordance with the NFPA number 25, 2002 edition. Maintenance is needed to be sure that the tank functions correctly. Tanks are to be painted regularly to prevent rusting. Before the inside of a gravity tank is repainted, the surface should be thoroughly dried. All loose paint, rust, scale, and other surface contamination should be removed. The outside of the gravity tank will require local patching. A complete finish coat of paint is needed when the paint has weathered thin. A new coat of paint also improves the appearance of the tank after it has been patched. Painters shall be careful that scrapings or other foreign materials do not fall down the outlet into the sprinkler piping. The discharge outlet may be covered for protection during repairs. Only a few sheets of paper or a paper bag tied over the end of the settling basin stub should be used. The paper should be removed immediately after the job is finished. It is best if gravity tanks are used only for fire protection and for no other purpose. Tanks used for other purposes need to be refilled more often. The tanks become settling basins for sediment mixed in with the water. This sediment is then drawn into the piping. This may cause the sprinkler system to become clogged and not work properly. The local firehouse should always be notified when a tank cannot be used for any reason. Pump inspection and maintenance. In order to ensure the reliable operation of the pump in the case of an emergency, regular inspections and maintenance shall be conducted by the certificate of fitness holder. The pump should be activated each week and run for 10 minutes in accordance to the manufacturer specifications to ensure that it is functioning properly. When the pump is in operation, a small water leak on the pump bearings is desirable and should not be considered a malfunction. If an automatic controller operates the fire pump, the pump shall be activated by reducing the water pressure in the system. This can be done by opening the test drain or initiating a large water flow from the system. By starting the fire pump this way, the certificate of fitness holder can determine if the automatic controller is working properly. Care should be taken to make sure that the pump does not overheat while conducting the test. The centrifugal pump relies on the water supply for cooling and lubrication and should never be operated without the pump being supplied with water. A visual inspection of all parts of the pump and the controlling equipment should also be conducted each week. This inspection should include the condition and reliability of the power supply. If any problems are discovered with the equipment, immediate action should be taken to correct the problem. Fire pumps should be fully tested annually to make sure that the pump, driver, power supply, and all other parts are functioning properly. Common deficiencies. The most common sprinkler system deficiencies include painted or loaded sprinkler heads, building contents located less than 18 inches below sprinkler deflectors, changes from the original wall locations, ceiling heights, and positioning of mechanical equipment. For concealed sprinkler systems, cover plates with non-factory coatings and the lack of required gap between cover plate and ceiling and blocking of the spray patterns from light fixtures too close to the sprinklers are the most common deficiencies seen in the field. Missing trim or cover plates not attached properly to sprinklers may indicate hanger deficiencies and may not allow the sprinkler deflectors to drop below the ceiling, blocking the spray pattern. The certificate of fitness holder shall assume that the system being inspected is installed in accordance with the New York City Building Code in effect at the time of installation. The certificate of fitness holder is to report those items of change that impact the system components regarding compliance with any retroactive requirements, the condition of the water supply control valves, water and air levels in reserve tanks and condition of same, unusual changes in water supply or system pressures, condition and accessibility of control valves, fire department connections, clearance around sprinkler heads, accessibility of the curb valve box, system control valves, required signage, attachments to piping other than system components, misaligned piping due to impact, missing pipe hangers and supports, excessive operation of pressure relief valves, easily recognized recalled sprinkler heads, and visible leakage. Factors that may require further investigation. Installations that don't appear to be correct, including sprinkler heads located more than 22 inches below the ceiling or structure, sprinklers not installed in accordance with their listing, using sprinklers with a different RTI in the same protected area or the wrong RTI for the occupancy classification, undersized piping, incompatible piping materials, flexible sprinkler hoses not attached to the building structure, along with areas of the building not protected by the sprinkler system. All require further investigation by a qualified master fire suppression piping contractor. When sprinklers are replaced, the following information is critical to be certain that the correct devices have been used. Sprinklers with different diameter glass bulbs will have a different RTI and must not be used together in the same compartment. Sprinklers replaced without a SIN identification must be replaced with devices that perform as residential/hotels group R or J in the pre-2008 code. Residential sprinklers are required in all sleeping compartments. Quick response sprinklers are required in all other portions of the facility. Business/office group B or E in pre-2008 code, institutional I or H in pre-2008 code, education E or G in pre-2008 code require quick response sprinklers be installed in all occupied areas. Glass bulb sprinklers are sensitive to damage and are required to be shipped from the factory with protection. The orange caps and straps need to be removed prior to putting the system in service. The sprinkler will fail to operate with them in place. A complete summary of tasks of inspection, maintenance, and testing. 1. Inspection. A. Sprinkler systems. Gauges. Dry, pre-action, and deluge systems shall be inspected weekly to ensure that normal air and water pressures are maintained. Where air pressure supervision is connected to a constantly attended location shall be inspected monthly. Wet pipe sprinkler systems shall be inspected monthly to ensure good condition and that normal water supply pressures are being maintained. Alarm devices. Alarm devices shall be inspected quarterly to verify that they are free of physical damage. Hydraulic nameplate. Hydraulically designed systems shall be inspected quarterly to ensure that the nameplate is attached securely to the sprinkler riser or sprinkler control valve and is legible. Buildings. Annually, prior to freezing weather, buildings with wet pipe systems shall be inspected to verify that windows, skylights, door ventilators, other openings and closures, blind spaces, unused attics, stair towers, roof houses, and low spaces under buildings do not expose water-filled sprinkler piping to freezing and to verify adequate heat with a minimum temperature of 40 degrees Fahrenheit. Hangers/seismic braces. Hangers installed in concealed spaces such as above suspended ceilings shall not need inspection. Hangers installed in areas that are inaccessible for safety considerations due to process operations shall be inspected during each scheduled shutdown. Hangers and braces shall be inspected annually from floor level to ensure they are in place, properly aligned and otherwise not damaged. All defects and deficiencies shall be corrected. Pipe and fittings shall be inspected annually from the floor level to ensure there is no mechanical damage, leakage, corrosion, misalignment, and that required supports and bracing are in place and are in good condition. Nothing shall be attached to any sprinkler system component. Pipe installed within concealed, such as above suspended ceiling spaces, are not required to be inspected. Exposed piping installed in areas that are inaccessible for safety considerations due to process operations shall be inspected during each scheduled shutdown. Pipe installed in areas that are inaccessible shall be inspected during each scheduled shutdown. Spare sprinkler heads/wrenches. The supply shall be inspected annually for the proper number and type of sprinklers and a sprinkler wrench for each type of sprinkler. Sprinklers. Sprinklers shall be inspected from the floor level annually for signs of leakage, corrosion, foreign materials, paint, and physical damage, and shall be installed in the proper orientation, such as upright, pendant, or sidewall. If the above problem occurs, the sprinkler shall be replaced. Glass bulb sprinklers shall be replaced if the bulbs have emptied. Unacceptable obstructions to spray patterns shall be corrected. Sprinklers installed in concealed spaces, such as above suspended ceilings, are not required to be inspected. Sprinklers installed in areas that are inaccessible for safety considerations due to process operations shall be inspected during each scheduled shutdown. B. Fire booster and special service pumps. Pump house and heating ventilating louvers. A visual inspection shall be performed weekly to ensure that the heat is not less than 40 degrees Fahrenheit and not less than 70 degrees Fahrenheit for pump rooms with diesel pumps without engine heaters, and that ventilating louvers are free to operate. Fire pump. Weekly visual inspections shall be made to ensure that the pump suction and discharge and the bypass valves are fully open. All piping is free of leaks. Suction line pressure gauge readings are normal and that the reservoir is full. System line pressure gauge readings are normal and that the wet pit suction screens are unobstructed and in place. Diesel engine fire pump system. Fuel system. A visual inspection shall be performed weekly to ensure that the tank level is 2/3 full. The tank float switch is in the auto position. Solenoid valves shall be operational. There is no water in the fuel system, and on the condition of the flexible hose connectors. Lubrication system. Weekly checks are required for the oil level in the right angle gear drive and to ensure that the lube oil heater is adequately lubricated. Cooling system. A visual inspection shall be performed weekly to ensure that levels for cooling water to the heat exchanger are adequate. Check on water pumps and on the condition of flexible hoses and connections. Annual inspections shall be done of all ductwork and cleaning of the louvers. Exhaust system. Weekly checks shall be done for any leakage and for the drain condensate trap. Quarterly check the insulation and for any fire hazards. Battery system. Weekly checks shall be made on the electrolyte level of the battery system along with the charger and charge rate. Monthly checks shall be made to remove any corrosion on the pump casing and to clean and dry the housing. Quarterly checks shall be made that all terminals are clean and tight. Electrical system. A visual inspection shall be performed weekly to ensure that the controller pilot light is on, the transfer switch is closed, the reverse phase alarm pilot light is off or on normal phase rotation, the pilot light is on, and that the oil level in the vertical motor sight glass is normal. Circuit breakers or fuses are to be checked monthly, and any potential wire chafing, where wire is subject to movement, shall be checked quarterly. C. Water storage tank. Condition of water in tank. Water level. Tanks without supervised water level alarms at constantly attended locations shall be inspected monthly. Tanks with supervised water level alarms at constantly attended locations shall be inspected quarterly. Water temperature. The temperature of water tanks shall not be less than 40 degrees Fahrenheit. The temperature of water in the tanks without low temperature alarms connected to a constantly attended location shall be inspected and recorded daily during the heating season. The temperature of water in the tanks with low temperature alarms connected to a constantly attended location shall be inspected and recorded weekly during the heating season. Air pressure. Air pressure without a supervised air pressure source shall be inspected monthly. Air pressure with a supervised air pressure source shall be inspected quarterly. Heating system. The heating system and components, including piping without a low temperature alarm, shall be inspected daily. The heating system and components, including piping with a low temperature alarm, shall be inspected weekly. Tank exterior. The exterior of the tank, supporting structure, vents, foundation, and catwalks or ladders, shall be inspected quarterly for damages and weakening. The area surrounding the tank shall be inspected quarterly to ensure it is free of combustible storage, trash, debris, brush, or material that could present a fire exposure hazard, and for any accumulation of material or ice buildup on or near parts that could result in accelerated corrosion or rot. The exterior side and top of embankments supporting coated fabric tanks shall be inspected and kept free of erosion. Expansion joints shall be inspected annually for leaks and cracks. Hoops and grillage of a wooden tank shall be inspected annually. Exterior painted, coated, or insulated surfaces of the tank and supporting structure, where provided, shall be inspected annually for signs of degradation. Interior inspection. The interior of steel tanks without corrosion protection shall be inspected every 3 years. The interior of all other types of tanks shall be inspected every 5 years. The tank interior shall be inspected for signs of pitting, corrosion, spalling, rot, and other forms of deterioration, waste material and debris, aquatic growth, and local or general failure of interior coating. D. Valve and valve components. Pre-action/deluge valves. The valve enclosure heating equipment is subject to freezing and shall be inspected daily during cold weather for its ability to maintain a minimum temperature of at least 40 degrees Fahrenheit. Valve enclosures equipped with low temperature alarms shall be inspected weekly during cold weather. Exterior valves shall be inspected monthly to ensure that they are free from physical damage, the valve seat is not leaking, that all trim valves are in the appropriate open or closed position, and that electrical components are in service. Interior. The interior of the valve and the condition of detection devices shall be inspected annually when the trip test is conducted. Internal inspection of valves that can be reset without removal of a faceplate shall be permitted to be conducted every 5 years. Strainers, filters, restricted orifices, and diaphragm chambers shall be inspected internally every 5 years, unless tests indicate a greater frequency is necessary. Dry pipe valves/quick opening devices. The valve enclosure heating equipment is subject to freezing shall be inspected daily during cold weather for its ability to maintain a minimum temperature of at least 40 degrees Fahrenheit. Valve enclosures equipped with low temperature alarms shall be inspected weekly during cold weather. Exterior dry pipe valves shall be inspected monthly to ensure they are free from physical damage, the intermediate chamber is not leaking, all trim valves are in the appropriate open or closed position, and electrical components are in service. The interior of the dry pipe valve shall be inspected annually when the trip test is conducted. Strainers, filters, restricted orifices, and diaphragm chambers shall be inspected internally every 5 years unless tests indicate a greater frequency is necessary. Backflow prevention assemblies. The double and single check assembly valves and double check detector assembly valves shall be inspected weekly to ensure that the O, S, and Y isolation valves are in the normal open position. Valves secured with locks or electrically supervised shall be inspected monthly. Fire department connections. Fire department connections shall be inspected quarterly to verify that the connections are visible and accessible and that the couplings or swivels are not damaged and rotate smoothly. Plugs or caps shall be in place and undamaged. Gaskets shall be in place and in good working condition. Verify that identification signs are in place regarding distance to the nearest fire hydrant. The check valve is fully operational and not leaking. The automatic drain valve shall be in place and properly operating, and that the clapper shall be in place and operating properly. Control valves. All indicating valves controlling water supply shall be sealed, locked, or provided with other approved methods as outlined in the National Fire Protection Association No. 25, 2002 edition. A seal is defined as an easily removable device, with no key required, that will indicate the unauthorized operation of a valve. Using this method shall require weekly inspections of each valve by the certificate of fitness holder. All indicating valves controlling water supplies equipped with locks that and/or are supervised shall be inspected monthly. The inspection shall verify that the valve is in the normal open or closed position, properly sealed, locked, or supervised, provided with appropriate wrenches, free from external leaks, and provided with the appropriate identification. Pressure reducing and relief valves. Fire pumps. Casing relief valves. All circulation relief valves shall be inspected weekly to verify that water flows through the valve when the fire pump is operating at shutoff pressure or churn to prevent the pump from overheating. Pressure relief valves shall be inspected weekly to verify that the pressure downstream of the relief valve fittings in the fire pump discharge piping does not exceed the pressure for which the system components are rated. Sprinkler systems. All valves shall be inspected quarterly to verify that the valves in the open position are not leaking and are in a good condition, with hand wheels installed and unbroken. Downstream pressures shall be maintained in accordance with the design criteria. Hose connections. All valves shall be inspected quarterly to ensure that the hand wheel is not broken or missing, and that the outlet hose threads are not damaged and are without leaks. The reducer and the cap shall not be missing. Hose racks. All valves shall be inspected quarterly to ensure that the hand wheel is not missing or broken and that there are no leaks. Alarm valves. Exterior alarm valves shall be inspected monthly to ensure the gauges indicate a normal supply water pressure is being maintained. The valve shall be free of physical damage and ensure that all valves are in the appropriate open or closed position. The retarding chamber or alarm drain shall be in a good condition without leaks. All alarm valves and their associated strainers, filters, and restricted orifices shall be inspected internally every 5 years unless tests indicate a greater frequency is necessary. Exterior valves shall be externally inspected monthly to ensure that they are free from physical damage, the valve seat is not leaking, all trim valves are in the appropriate open or closed position, and electrical components are in service. Exterior dry pipe valves shall be externally inspected monthly to ensure that they are free from physical damage, the intermediate chamber is not leaking, all trim valves are in the appropriate open or closed position, and electrical components are in service. Check valves shall be inspected internally every 5 years to verify that all components operate correctly, move freely, and are in good condition. 2. Testing. A. Sprinkler systems. Alarm devices. Water flow alarms on wet pipe systems shall be tested quarterly. Vane-type water flow devices shall be tested semi-annually. Water flow alarms on wet pipe systems shall be done by opening the inspector's test connection. If a freezing weather conditions or other conditions disallow the use of the test connection, the bypass connection shall be permitted to test. Main drains. The test shall be conducted annually at each water-based fire protection system riser to determine whether there has been change in the condition of the water supply, piping, and control valves. Antifreeze solution. The freezing point of solutions in antifreeze shall be tested annually by measuring the specific gravity with hydrometer or refractometer and adjusting solutions if necessary. Antifreeze concentrations of glycerin shall not exceed 50%, and if propylene glycol, not exceed 40%. Gauges. Gauges shall be replaced every 5 years or tested every 5 years by comparison with a calibrated gauge. Gauges that are not accurate within 3% of the full scale shall be recalibrated or replaced. Sprinklers. Extra high temperature. Representative samples of solder-type sprinklers with a temperature classification of extra high 325 degrees Fahrenheit or greater that are exposed to semi-continuous to continuous maximum allowable ambient temperature condition shall be tested at 5-year intervals. Sprinklers, fast response. Tested at 5-year using fast response elements that have been in service for 20 years shall be tested. They shall be retested at 10-year intervals. Sprinklers from sample areas that do not pass performance standards shall be replaced. Old sprinklers. Where sprinklers have been in service for 50 years shall be replaced, or representative samples from one of more sample areas shall be tested. Sprinklers from sample areas that do not pass performance tests shall be replaced. Test procedures shall be repeated at 10-year intervals. All sprinkler heads manufactured prior to 1920 shall be replaced. B. Fire booster and special service pumps. Pump operation. A weekly test of fire pump assemblies shall be conducted without flowing water and shall be conducted by starting the pump automatically. An electric pump shall run a minimum of 10 minutes and diesel pumps shall run a minimum of 30 minutes. An annual test of each pump assembly shall be conducted under minimum rated and peak flows of the fire pump by controlling the quantity of water discharged through approved test devices. C. Water storage tank. Temperature alarms. Low water temperature alarms shall be tested monthly, in cold weather only. High temperature limit switches. High water temperature limit switches on tank heating systems shall be tested monthly, whenever the heating system is in service. Water level alarms. High and low water level alarms shall be tested semi-annually. Level indicator. Level indicators shall be tested every 5 years for accuracy and freedom of movement. Pressure gauges. Pressure gauges shall be tested every 5 years with a calibrated gauge according to the manufacturer's manual. Gauges not accurate to within 3% of the scale of gauge being tested shall be recalibrated or replaced. C. Valve and valve components. Main drain test. This test shall be conducted annually at each water-based fire protection system riser to determine whether there has been a change in the condition of the water supply piping and control valves. Water flow alarms shall be tested quarterly in accordance with the manufacturer's instructions. Control valves. Each control valve shall be operated annually through its full range and returned to its normal position. This test shall be conducted every time the valve is closed. Post indicator and outside screw and yoke valves shall be backed a 1/4 turn from the fully open position to prevent jamming. Valve supervisory switches shall be tested semi-annually. A distinctive signal shall indicate movement from the valve's normal position during either the first 2 revolutions of a hand wheel or when the stem of the valve has moved no more than 1/5 of the distance from its normal position. Pre-action/deluge valves. The priming water level in supervised pre-action systems shall be tested quarterly in accordance with the manufacturer's instructions. Low air pressure alarms shall be tested quarterly in accordance with the manufacturer's instructions. Each deluge or pre-action valve shall be trip tested annually at full flow in warm weather and in accordance with the manufacturer's instructions. Protection shall be provided for any devices subject to damage by system discharge during tests. Dry pipe valve/quick opening devices. The priming water level shall be tested quarterly. High priming water levels can affect the operation of supervisory air or nitrogen pressure maintenance devices. Testing the water level is done by opening the priming level test valve. If water flows, drain it. Close the valve when water stops flowing and air discharges. If air discharges when the valve is opened, the priming water level could be too low. To add priming water, refer to the manufacturer's instructions. Low air pressure alarms shall be tested quarterly in accordance with the manufacturer's instructions. Quick opening devices shall be tested quarterly following the following procedures. Close the system control valve, open the main drain valve and keep it in the open position, Verify that the quick opening device control valve is open. Open the inspector's test valve. A burst of air from the device indicates that it has tripped. Close the device's control valve. Return the device to service in accordance with the manufacturer's instructions, and return the system to service. Each dry pipe valve shall be trip tested annually during warm weather. It should be tested in the spring to allow time before the onset of cold weather for all water that has entered the system or condensation to drain to low points or back to the valve. Every 3 years and whenever the system is altered, the dry pipe valve shall be trip tested with the control valve fully open and the quick opening device in service. A full flow trip test requires at least 2 individuals, one of whom is situated at the dry pipe valve while the other is at the inspector's test. If possible, they should be in communication with each other. A full flow trip test is conducted as follows. 1. The main drain valve is fully open to clean any accumulated scale or foreign material from the supply water piping. The main drain valve is then closed. 2. The system air or nitrogen pressure and the supply water pressure are recorded. 3. The system air or nitrogen pressure is relieved by opening the inspector's test valve completely. Concurrent with opening the valve, both testers start their stopwatches. If two-way communication is not available, the tester at the dry valve is to react to the start of downward movement on the air pressure gauge. 4. Testers at the dry pipe valve note the air pressure at which the valve trips and note the tripping time. 5. Testers at the inspector's test note the time at which water flows steadily from the test connection. This time is noted for comparison purposes to previous tests and is not meant to be a specific pass-fail criterion. Note that the National Fire Protection Association No. 13 does not require water delivery in 60 seconds for all systems. 6. When clean water flows, the test is terminated by closing the system control valve. 7. The air or nitrogen pressure and the time elapsed are to be recorded as follows. A. From the complete opening of the test valve to the tripping of the valve. B. From the complete opening of the inspector's valve to the start of a steady flow from the test connection. 8. All low point drains are opened and then closed when water ceases to flow. The dry pipe valve and quick opening are reset, if installed, in accordance with the manufacturer's instruction, and the system is returned to service. Pressure reducing and relief valves. Sprinkler systems. At 5-year intervals, a full flow test shall be conducted on pressure reducing valves and shall be compared to previous test results and the results from the original installation or acceptance test. Annually, a partial flow test shall be conducted with a flow rate great enough to lift the valve seat. Section 12.5.1.3 of the National Fire Protection Association No. 25. Circulation relief. During the annual fire pump test, the closure of the circulation relief valve shall be verified to be in accordance with the manufacturer's specifications. Pressure relief valves. During the annual fire pump flow test, the pressure relief valve shall be verified to be correctly adjusted and set to relieve at the correct pressure and to close below that pressure setting. Sprinkler systems equipped with hose racks. A full flow test shall be conducted on each valve at 5-year intervals and shall be compared to previous test results. Backflow prevention assemblies installed in fire protection system piping shall be tested annually in accordance with the following. 1. A forward flow test shall be conducted at the system demand, including hose stream demand, where hydrants or inside hose stations are located downstream of the backflow preventer. 2. A backflow performance test, as required by the authority having jurisdiction, shall be conducted at the completion of the forward flow test. 3. Maintenance. A. Sprinkler systems. Obstruction investigation. An investigation of piping and conditions shall be done every 5 years by opening a flushing connection at the end of one main and by removing the sprinkler toward the end of one branch line for the purpose of investigating for the presence of foreign organic and inorganic material. Low point drain, dry pipe system. Shall be drained after each operation and before the onset of freezing weather conditions. B. Fire booster and special service pumps. A preventative maintenance program shall be maintained on all components of the pump assembly in accordance with the manufacturer's recommendations. If there is no manufacturer's recommendations for preventative maintenance, use Table 8.5.3 of the NFPA No. 25, 2002. C. Water storage tank. Water level. The tank shall be maintained full or at the designed water level. Drain silt. Silt shall be removed during interior inspection, semi-annually, or more frequently as needed to avoid accumulation to the level of the tank outlet. ESCF, embankment-supported coated fabric suction tanks. The maintenance of ESCF tanks shall be done according to the tank manufacturer manual. D. Valve and valve components. Control valves. The operating stems of outside screw and yoke valves shall be lubricated annually. The valve then shall be completely closed and reopened to test its operation and distribute the lubricant. Pre-action/deluge valves. During the annual trip test, the interior of the pre-action or deluge valve shall be cleaned thoroughly and the parts replaced or repaired as necessary. Dry pipe valves/quick opening devices. During the annual trip test, the interior of the pre-action or deluge valve shall be cleaned thoroughly and the parts replaced or repaired as necessary. The material covered in this chapter is repeated in Chapter 13 in the form of checklists of all required inspection, testing, and maintenance for water-based fire suppression piping systems. Chapter 13 will not be covered in this series. Those exact checklists will be provided to you when you take the exam at the fire department facility. While you need not memorize all of the information in this chapter, this is a timed exam. The checklists consist of approximately 22 pages, and you will only have an average of 2 minutes to answer each question. The more familiar you are with this content, the faster you will be able to locate the information in the booklet when questions pertaining to this material come up on the test. It is highly recommended that you download all 22 pages of Chapter 13 from the FDNY website, have the checklists printed out, and have the physical copies to refer to when taking the practice test. Repeatedly referring to physical copies of the actual checklists used in the exam while taking repeated practice tests is the best way to prepare yourself to handle those particular questions and complete the test in the allotted time. Chapter 14. Local Law 58 of 2009. Fire suppression piping components as required by Local Law 58/2009. Note: only existing visible piping shall be identified as required. When ceilings are removed during renovations, any existing visible system piping shall be identified and painted. Standpipe and sprinkler feed mains. The portion of the standpipe or sprinkler system piping that supplies water to one or more standpipe or sprinkler risers. Standpipe and sprinkler cross connections. The portion of the standpipe or sprinkler system that interconnects the feed mains and risers to the fire department connections. Standpipe and sprinkler risers. The vertical portion of the system piping that delivers the water supply for hose connections and sprinklers on standalone as well as combined systems, vertically from floor to floor. Fire department connections. The portion of the standpipe or sprinkler system that is connected to the fire department pumper connection and supplies the standpipe and sprinkler feed mains, cross connections, and risers. All handles of indicating valves. These handles control the water supplies to the standpipe and sprinkler systems. Street water supply. The portion of system piping connected to the discharge of the water meter to the main sprinkler control valves. All pipe material identification information, if present, shall not be painted. Fire suppression piping components not required to be identified as required by Local Law 58/2009. Fire department hose valve bodies and handles, indicating control valve bodies, check valves, jockey pump control valves, trim, test, and drain valve handles. Standpipe, branch piping. The portion of the piping system connecting one or more hose valve stations. Sprinkler cross mains. The portion of the piping system connecting supplying the branch lines either directly or through risers. Sprinkler feed mains. The portion of the piping system downstream of a sectional or floor control valve supplying cross mains. Sprinkler branch piping. The portion of the piping system to which the sprinkler heads or nozzles are directly connected to. For more info, refer to New York City Building Code, Local Law 58/2009. Standpipes and sprinklers. New safety regulations. New standpipe and sprinkler piping laws went into effect in 2010. Building owners and contractors must be sure their properties and projects comply with these new local laws. The Buildings Department participated in the multi-agency advisory group that proposed these new safety standards. To learn more, read Strengthening the Safety, Oversight and Coordination of Construction, Demolition and Abatement Operations, available at nyc.gov/buildings. Color coding. Local Law 58 of 2009, effective the 2nd of March 2010. Existing buildings must comply by the 2nd of June 2010. All exposed standpipes and sprinkler piping must be painted red. The law outlines specific exceptions, such as branch piping. All buildings, no matter the size or occupancy, must comply with these new requirements. Dedicated standpipe valve handles must be painted red. Combination standpipe valve handles must be painted yellow. Dedicated sprinkler valve handles must be painted green. Cutting and capping. Local Law 60 of 2009, effective the 2nd of March 2010. Permits are required to cut and cap standpipes or sprinklers. Authorized licensees. Only licensed master plumbers or licensed master fire suppression piping contractors may cut and cap standpipes or sprinklers during demolition. Local law incorporates Technical Policy and Procedure Notice 3 of 2007, which became codified in Local Law 60 of 2009. For demolitions and gut rehabilitations, a registered design professional must have a variance to remove damaged or inoperable sprinklers. This filing must include a damage report and an explanation why the system can't be restored. The design profession must first file the variance with the fire department and have FDNY approval before filing it with the Buildings Department. Color coding certification. Buildings under construction. The special inspector will confirm compliance before the walls are enclosed. Existing buildings. Owners of buildings with exposed sprinkler piping and standpipes must comply and hire one of 4 types of contractors to certify the color coding. Licensed master plumbers, licensed master fire suppression piping contractors, registered design professionals, or people with the appropriate fire department certificate of fitness. Proof of color coding certification. The color coding certification must be kept on the premises at all times for buildings and fire department inspection. Visit nyc.gov/buildings for the certification form, available online. Chapter 15. Obstruction Investigation. The presence of obstructions in sprinkler systems shall be checked every 5 years by opening a flushing connection at the end of one main per system. One sprinkler head per system toward the end of one branch line shall also be removed. This is done for investigating for the presence of foreign organic or inorganic material. Sources of obstructions to piping include but are not limited to pipe scale, careless installation or repair, raw water sources, biological growth, sprinkler calcium carbonate deposits, and MIC, or microbiologically influenced corrosion. Inorganic material would include, but not be limited to, silt, sand, rocks, gravel, and construction debris. Organic material includes wood, microbes, and zebra mussels. While zebra mussels are not reported in the New York City area, the Hudson River contains this predator, and it is possible that contamination may occur in New York City's upstate water supplies. When tubercules and slime are found during the investigation, they shall be tested for MIC. An obstruction investigation shall also be performed whenever the following conditions exist, such as pinhole leaks, a record of broken public water mains in the vicinity, foreign material and water discharged during drain tests, or plugging of an inspector's test valve connection. A complete list of system conditions requiring obstruction investigation are listed in Chapter 13 and Annex D of the National Fire Protection Association No. 25, 2002 edition. Chapter 16 is photographic reference of the various sprinkler heads, with some additional hardware used in sprinkler systems. Refer to pages 81 through 89 of the Fire Department's transcript. This concludes all 10 volumes of the Complete Test Preparation Series for the New York City Fire Department S-12 Certificate of Fitness for Citywide Sprinkler Systems course. I hope that this audio transcription has helped you to better prepare for the exam. Repeat this series as often as you need until you feel confident with the material. When you are ready, proceed to the practice exams to test your knowledge. Post any follow-up questions in the comment section below. Subscribe to stay current on updates to existing exams and to be notified of new test preparation content. If you found this video helpful, please leave a like. I wish you the best of luck on your exam. Let me know how you did and post your test scores in the comment section.